All right, Calculus, and we're back. I did not expect a video 2, but I just got robocalled, which shut down this iPad, or at least shut down the last video. So now we have video 2. The phone is off. Can't be robocalled here. All right. Again, remember the product, power, and quotient rule with logs for 10a and 10b. How did we get x squared minus 9? We multiplied those two. All right. Find the exact value. Log base 3 of 1 over 81 is equal to x. X is the exponent. The exponent is negative 4. You're going to write it as natural log of e to the negative fifth, which is negative 5. Okay. Again, use those 3 power, product, and quotient rules. All right. That is exactly 2. When it says find the exact answer, if it is a decimal, it would be a good decimal, like 2.5 or something. Exact answer, 3 over 2, 5 over 2, in that case, 2. All right, this is just simple work with exponents, literally from Algebra 1 or Algebra 2. That shouldn't cause this issue. So in here, add the exponents to the numerator, then subtract the exponents. And then I believe these might be the last questions from your first exam. Okay, find sine of theta. If cosine of theta is 7 over 10, sine of theta would be root 51 over 10. Sine inverse. It's going to give you angles in the fourth and first quadrant. If it's negative, it's in the fourth quadrant, okay? So theta's got a sine ratio of negative 2 over 3. It's got a cosine ratio of root 5 over 3. All right, exam number 2. Here are the answers, taking now limits. That one we just simply plug in, folks. Too many of us missed. We tried to factor, simply plug it in. If you don't get a denominator of 0, feel good about it. Here you do, you get 0 over 0, which is indeterminate. So you need to first take out the 2 and then factor. 16 is what you get. Right here, again, you get 0 over 0, so we have to factor the top. We'll cancel time. Now I can plug negative 2 in. That's what I get. Again, I'm going to kind of go through this fast, so pause it. I would get 0 over 0 again, so when I factor and cancel, remember, these are exact opposites, so the cancel would be negative 1. Be very careful. Plug 7 in. Negative 11. This next one, x times the square root of x is x to the 3 halves. The square root of x to the third is x to the 3 halves. You have the same highest power, so it's the ratio 7 over 4. Again, it's just those horizontal asymptote rules. We got a factor number 6. There we go. Number 7, back to factoring. Okay. Then I can plug 3 in. Be very careful. Be very careful. Here's where we multiply top and bottom by the conjugate. Again, you want the root gone, so maybe in Algebra 2 this is a fine answer, but not if we're going to let x be 2. Got to multiply top and bottom by the conjugate of root 8x minus 4. Okay, factor out the 8. The x minus 2's cancel, and then I can plug 2 in for x. All right. Evaluate each limit if it exists. So the limit as limit of f of x as x goes to negative 3 from the left, you can plug negative 3 into the first equation because from the left side it's less than negative 3. From negative 3 from the right, you plug it into the second equation because to the right of negative 3 would be just bigger than negative 3. 6, the left-hand limit does not equal the right-hand limit. You got to show me that. That's why they do not exist. From the left side of 4 would be an equation 2. Plug 4 in there. Right side of 4 would be equation 3. Plug it in there. Again, negative 9 does not equal 20. The limit as a whole does not exist. Find the value of c so that f is continuous on its whole domain. So if I want continuity, I cannot pick up the pencil when I make that graph, so I need the same y value. That means 10 minus 7x must give me the same y value as c, x squared plus 4x minus 7. Plug negative 5 in to both and set them equal to each other. Expect fractions. All right, now here's the thing, folks. You can now find the equation of the tangent line to any curve using simple derivative rules. Okay, this is a much easier problem than it was in chapter 2 now. Bring down the power, 1 power less, chain rule, plug 6 in for x, 3/8. Again, we should not miss these, even with roots. This one's very easy. The derivative is just negative 2x, plug negative 2 in for x. Slope is 4, boom. All right, and we keep going. For 13 here, another easy derivative, plug 1 in for x, get a slope of 4. Okay, the derivative is 3x squared minus 12x. Where we plug it in for x, 2. Get a slope of negative 12. There it is. And find f prime of x, or a, by using the limit definition. Now, if I do tell you have to use the limit definition, that's the limit definition, okay? Again, the only thing that's different, I mean, we could plug x in there and x in there, and again, the difference quotient there is the limit definition of the derivative. Okay, so I know my derivative's got to be 14x plus 3. So I know after doing this, all this canceling, I need to get a 14a plus 3. Okay, which I forgot. Yeah, notice how it did say minus 7h, but I tried to erase it, not erase it, but blot it out there because I'm letting h go to 0. So 14a plus 3 is what remains. We can talk more about that one too if we have a review day in between. Use the intermittent value theorem to show that there exists a root of the equation in the given interval. So I've got to cross the x-axis between x equals 3 and x equals 4. Plug 3 in for x, I get negative 6. Plug 4 in for x, I get 6. That means I had to have crossed 0 in between. All right, and you have shown that. And lastly, on exam 2, find the instantaneous velocity at time t equals 3. I didn't say you had to use the limit definition, so find the general derivative. So v of t, this is the same thing. H prime of t means v of t. Is that plug 3 in negative 36 feet per second. Okay, do use the proper units there. Okay, and then we've seen this before, exam number 3 review. Find just the general derivative there. Pretty easy power rule. Same on number 3. I'll go in this order. Divide everything by x to the third. So that it's that first. Then take the derivative. That's simple power rule. Or yeah, power rule. Another very easy power rule question. Okay, again, rewrite this power rule. Bring down the power, 1 power down. I would distribute x to the 1/2. So that's what we get. Then an easy power rule again. All right. Next page. Here's what I did. I FOILed everything, then a simple power rule. If you wanted to do the chain rule, fine. Bring down the 2. Rewrite 12 minus 5x. Take the derivative of negative, or 12 minus 5x. Then you still have to distribute and multiply. So you might as well do that off the get-go. Divide everything by x. That will make, first off, you'll get then the actual true simplified answer. And that will make low d high minus high d low all over the square roots below. Much easier. That is the quotient rule. Here, again, that is 3 times x to the 1/2. The 3 is on the outside. Distribute that through. Power rule time. This one looks very much like number 9, but you can't divide everything by x. So that is the quotient rule, low d high minus high d low, all over the square of what's below. I use distribution, and I do recommend that sometimes. We have issues if we try to use the whole power. If we use the product rule here, first off, you're still going to have to distribute. I think I tried that right off the bat, and it's not going to be any less work. So distribute, take your time. This is from Algebra 2, Chapter 5. And then take the derivative using the power rule. And number 12. Divide everything by x to the 1/2. So take a 1/2 power away from each for x. And then it is the power rule. All right, so equation of the tangent line. Again, on all of these questions, you can use simple derivatives. Plug 2 in, that's the slope 13. Here, the derivative is 7 minus 6x. Plug -1 in, you go to another slope of 13. All right, x to the 1/2 has that derivative, 1/2, or 1 over 2 root x. Plug 9 in for x, your slope is a 6th. There we go, then pause this whenever you need to. Low d high minus high d low, all over the square of what's below. We get a nice derivative. All right, pretty nice derivative there. Plug 1 in for x. That's your slope, 7/9. All right, making good progress here. Find the instantaneous velocity. Again, take the general derivative, -32t plus 85. Then you're going to plug in 2.5. Then you're going to plug in 4. So at 4, it's coming down. Then you're going to plug in 1.5. It's going up. Positive velocity is that. Find the velocity accelerations as functions of t, v of t, a of t. Find the acceleration after 2.5 seconds. There we go. Feet per second squared. All right, take the derivative. You have the products rule with a little bit of the chain in there for 19. Let's talk about 20. That is a simple, relatively simple chain rule. And pause this whenever you need to. There's 21. You've got the product rule, either 2x. Yes, you're going to do the chain rule. Take the derivative of 2x at the end. Here, I would divide everything by x to the 3/2. Then you can use the simple power rule. That's minus 27 over 2, x to the 7 over 2. That is u to the 1/2, so it's 1/2 u to the -1/2 times the derivative of u. Make sure you have that exponent there. Too many students in your third exam forgot it and then used distribution, and that is way wrong. That is not a good error. Here, I would, now some of you might have called it 1 over cosine times sine over cosine. I wouldn't use the quotient rule there. Just do the product rule. Okay. Next one, that is a very simple power rule question. There, I would definitely, if I were you, again, some of you called it 3x to the third times x squared minus 3 all to the -1/2. That's fine. You can do it like that. No big deal. You actually got a better answer. Here, I just used the quotient rule. All right. Then, next page, quotient rule, low d high minus high d low, all over the square of what's below. Yes, you need to know that sine squared plus cosine squared is 1. It's got to be 1 you got to know, okay? You could distribute, but then you would have 9 terms. You might as well just use the chain rule there, and then you'll distribute with 6 terms, and you'll simplify it. Chain rule, natural log of u, the derivative is 1 over u times the derivative of u. Derivative of u would be negative sine of that times the derivative of that. That's why you're multiplying. That's not a minus sine 2x times 2. You're multiplying that by that, okay? If you wanted to call that -2 tangent of 2x, fine. 1 over u times the derivative of u. Okay, again, if you wanted to call that cotangent of 3x, fine. This is the product rule with a little bit of chain there in the second part. There we go. And divide everything by x, and you have a pretty easy quotient rule question with a nice answer. All right. Then we have find y prime, implicit differentiation. There we go. 34. Take your time with that. Again, check your answer. Again, at this stage, folks, it's about checking your answer because you should know how to do that. Got the product rule on that one. All right, rewrite it as 2x to the 1/2 plus y to the 1/2. We've only got one y prime. We're simplifying. Then we move over. First we move that over. Then we're going to divide by this, which means that's going to be up top because we're going to multiply by the reciprocal of that. It's a negative because this was a positive, and over there it's a negative. Got rid of 36, so hint, hint, wink, wink. 37, though, is pretty fair. There's 37. Got two y primes on the left. Anything that doesn't have a y prime, it gets moved over. No 38. And, folks, we will talk about the y double primes. You also have those in your chapter or in your exam number 3 review video. But that is a great video for now, folks. All right, practice, practice, practice. Watch this video. Then come see me Wednesday before school or for a copy of these answers, because I will do that as well. Yak Math Videos signing out.